Alright, so today we have really interesting, I would say like really tricky algebra question. We know a sum x plus y equal to 15 and a product x times y equal to 25. We need to solve this question for x and y, so if you have your solution, if you're interested in this, you can also solve this question with me right now, and in the end we will check our answers. Okay, so this is very basic algebra question, that's why we're going to express from the first equation, let's express our y. Okay, so this is our first step, so our from first equation, our y equal to 15 minus x. Okay, 15 minus x. Okay, and right now let's plug in this expression to the second equation. We have absolutely the same y in the second equation, but we're not going to plug in y. We're going to plug in 15 minus x. So let's do it. So we have x, and right now 15 minus x, 15 minus x, and equal to 25. Right now we have only one variable, so we don't have a y, we have only our x. So let's solve this question for x. It's much easier for us to work with only one variable. So x times this parenthesis, we have 15x minus x squared and equal to 25. And it looks like this is a quadratic equation, but we prefer a little bit different order. Let's write minus x squared on the first position, so minus x square on the first position, on the second position plus 15x, and minus 25 from our right side, so minus 25 equal to 0. And final really tricky moment, because we don't like this negative sign in the beginning, so that's why let's multiply both sides by minus 1. Okay, let's do it. So let's multiply both sides by minus 1. Our final quadratic equation, x squared minus 15x and plus 25 equal to 0. So this is our quadratic equation, and right now let's solve it. There are a lot of methods, but I'm going to choose this one because maybe a lot of students here, a lot of students who may be learning mathematics, so that's why I'm going to use basic method of coefficients. So a equal to 1, first coefficient, second coefficient minus 15, so b equal to minus 15, and c, third coefficient c equal to 25. So c equal to 25. And right now let's plug in everything. We know everything, we know all of this coefficients, so that's why let's start with discriminant real quick and then plug in with this discriminant to all known formula. So that's why we have discriminant b squared minus 40c equal to b squared, so we have minus 15 squared minus 4 times 1 and times c times 25. Okay, times 25 equal to, so from here minus 15 squared equal to 225 minus 4 times 1 times 25 equal to 100. Okay, 100, and from here our discriminant is negative, so 125. 125 is greater than 0, so it means that right here we have two real number root. It looks like that, but let's check it. So we have two pairs of root, x first and x second. So let's do it. So x first and x second. Right now let's write our all known formula, minus b plus minus square root of discriminant and all over to a. So we know everything. We know a, b, and we also know this discriminant. So minus b minus 15 plus minus square root of discriminant, discriminant, where do we have it? We have it right here, 125, and all over to a, 2 times 1 equal to. Minus equal to plus if you're talking about multiplication, so that's why we simplify this. So we have 15 plus minus 125. This is not like a table case. We know 100 square root of 100 equal to 10, square root of 121 equal to 11, but this 125 is also really great constant because we can express this as 25 times 5, yeah, all over 2. And right now this square root sign we can easily split, like we can write it as square root of 25 times square root of 5. This is all known square root property, all over 2. So I hope you understand this expression. And right now let's look at this question from different perspective. We don't have 125, we don't have 25 times 5, we have only square root of 25, and this is our table case. This is equal to 5. So as a result we have 15 plus minus 5 square root of 5, 5 square root of 5, all over all over 2. And of course, there are a lot of ways how can we solve another part, because just keep in mind that we need to solve this question also for y. So for further calculations, of course, this is up to you. I'm going to use a decimal way. I'm going to divide 15 over 2. So I'm going to write it like that, 15 over 2 plus minus 5 square root of 5 over 2. That's why I'm going to work with the decimal values. 15 half equal to 7.5. Yeah, 7.5 plus minus 2.5, 2.5 square root of 5, or let's leave it like that. Okay, let's leave it like that without any changes. Maybe it will be easier for us. Okay, 5 square root of 5 over 2. Okay, because then we will subtract 15, okay, right here. So just remember this expression. So that's why I'm going to use this type of expression. So let's write our final answer. So let's gather all the informations together, and let's write our x first. Let's write this expression, but with the plus sign. This is our x first, so 7.5 plus minus 5 square root of 5 over 2, and x second, don't forget about that we have right here plus minus, so that's why we have also x second equal to 7.5 minus 5 square root of 5 over 2. Okay, and right now let's go to the beginning. As I said before, we need to solve this question for x and y. So that's why it's really important for us to remember this. So y equal to 15 minus x, okay? Y equal to 15 minus x. Okay, let's do it. So let's write this exclamation mark because this is really important expression. So y equal to 15 minus x. And right now let's find a y first. Let's write here y second. So let's do it. So y first equal to 15 minus x first. 15 minus x first. So y first equal to 15 minus this x first. So we have 7.5 plus minus 5 square root of 5 over 2. Right now let's multiply this minus 1 by this parenthesis, so that's why we need to change all this signs. So y first equal to 15 minus 7.5 and minus 5 square root of 5 over 2, and of course right here minus, we don't need this negative sign on the bottom, right here plus, yeah. And right now that's why I use this expression 7.5. So we have 15 minus 7.5. It's much easier for us to subtract, yeah. So we have y first equal to 7.5 minus 5 square root of 5 over 2. So that's why I use this interpretation with decimal value, because it's much easier for us to subtract 15 minus 7.5. Okay, I really hope you understand it. Okay, and right now let's solve this for another part. Let's solve it for y second. So y second equal to 15 minus x second. We know this x second, so y second equal to 15 minus x second, 7.5 minus 5 square root of 5 over 2. So y second equal to, of course, right here with the parentheses, and right now when we multiply it by, when we multiply this negative sign by this parenthesis, so we have 15 minus 7.5 plus 5 square root of 5 over 2. And right now we have absolutely the same thing. It's much easier for us to subtract in a decimal way. It's much faster for us, so we have 7.5 plus 5 square root of 5 over 2. So right here we have our answer. We have a first pair x first, y first, and second pair x second, y second. So let's gather all the roots together, and in the end let's check our roots. First of all, let's write our final answer. Our answer to this question, our x first equal to 7.5. So this expression right here, we have it on the top of the paper. So we have 7.5 plus 5 square root of 5 over 2. This is our x first, and y first right here. So 7, as you can see, our roots are absolutely symmetrical with each other because we have absolutely the same constant but only different signs. And right here second pair absolutely the same but in a different order. So that's why we have 7.5 minus 5 square root of 5 over 2, and second one 7.5 plus 5 square root of 5 over 2. Okay, so we have our answer. I really hope you understand it. And in the end, let's check real quick our roots. First of all, let's write our question. So x plus y equal to 15, and a product xy equal to 25. Okay, so xy equal to 25. Right now, let's check real quick our, for example, addition at first. And its addition is also really interesting and really great mathematical operation, because we don't need to check both of these pairs. We can check only one of these because our pairs are absolutely symmetrical, and x plus y is the same as y plus x. So we will have absolutely the same answer. So let's check, for example, this one. So 7.5 plus 5 square root of 5 over 2 plus 7.5 minus 5 square root of 5 over 2. So right here we can easily cancel our expressions, and we have only 7.5 plus 7.5 equal to 15, and we have it right here. So our addition works perfectly. And in the end, let's check our multiplication. So that's why we have absolutely the same thing, but with parentheses. So 7.5 plus 5 square root of 5 over 2, and we multiply it by 7.5 minus 5 square root of 5 over 2 equal to, and right now I'm going to say one really important and tricky moment, because a lot of students might be multiplying parentheses by parentheses, but I really hope you understand and you remember these things from school, which is called like difference of squares. This is all known formula. So we have x squared minus y squared equal to x plus y times x minus y. And right now, let's look closely what do we have in our question. For example, this is our x, this is our y. So we have x plus y and x minus y. So this is our difference, a difference of squares. Okay, and right now, let's apply it. So this difference of squares. So 7.5 square minus 5 square root of 5 over 2 also to the second power. Right now, it's much easier for us to work with the squares in a different way. We can write it as 15 half, so we can go back to the beginning. So this is 15 half over 2. So with squares, it's much different to work with the fractions, okay, because it's much longer to multiply it. Minus 5 square root of 5 to the second power equal to 25 times 5, 20, what do we have it right here? 25 times 5 equal to 125, yeah, 125, over 2 square equal to 4. So as a result, our final move, 15 square 225 over 2 square equal to 4 minus 125 over 4, and as a result we have absolutely the same denominator, so we can easily subtract our numerators. So we have 100 over 4 equal to 25, and we have absolutely the same thing right here. So xy equal to 25, sorry. Okay, and I really hope you understand it. I really hope you learned something new. It is my solution to this question. Yeah, we have this long and I would say like a good solution. If you still have any notes, if you still have any question, assumptions, you can also write it in the comments below. What do you prefer, working with the decimal values right here at this place, or maybe fractions? From my perspective, it's much easier to work with the decimal value at this place, and of course, if you want to prove this, for me, much easier to work with the fractions when we need to raise expression to the second power. But this is from my perspective. Also write your thoughts, your response in the comments below. It will be really interesting to read about it. So take care of yourself, have a great day, see you in the next videos.